Windshield repair is the process of removing air from a brake, either by vacuum or displacement, and filling the brake with resin. Windshield repair has many benefits. The most important benefit is that it restores the structural integrity of the glass. A damaged windshield is unstable and could fail completely at any time. Properly completed repairs have a success rate of over 99% against the damage spreading. By repairing a windshield, the original factory seal is retained. Because the windshield is an integral part of the airbag deployment system and cab support, this is another significant safety benefit. ABC's 2020 news program reported that 80% of windshield replacements are not done correctly and can fail during a collision. The most obvious benefit of windshield repair is that it dramatically improves visibility and appearance of the windshield. By eliminating the air from the brake and filling it with Delta Kit's resins that are optically matched to the glass, your customer will have a better looking windshield. It is important to remember that windshield repair does not make damage disappear. A small scar will always be visible. Everyone likes saving money, and relative to windshield replacement, windshield repair is more cost effective. Most repairs bill out between $50 and $100, while replacement glass alone can run several $100s up to several thousand. Windshield repair also meets the need for convenience. The average repair time is around 15 minutes, compared to several hours for a replacement. Windshield repair conserves natural resources and reduces waste. Because laminated glass cannot be recycled economically, it ends up in landfills. Millions of tons of auto glass end up in landfills every year. Alternatively, the waste from a windshield repair will easily fit in the palm of your hand. There are several types of brakes you'll encounter and need to be familiar with. A bullseye is a separated cone in the outer layer of glass that results in a dark circle with an impact point. A star brake exhibits a series of legs that emanate from the brake, giving it the appearance of a star. This type of brake has multiple variations and are sometimes referred to as bat wings. A combination brake is damage that possesses multiple characteristics. This could be a star within a bullseye, or a short or long crack emanating from the damage. A surface pit is a nick in the glass and is associated with normal wear and tear. Surface pits do not penetrate to the polyvinyl butyl layer of the windshield. Windshield cracks come in all shapes and sizes. A short crack is anything 6 inches in length or less, while a long crack is anything over 6 inches. An edge crack is a crack that extends to any edge of the windshield. If you have a crack that extends to any edge but lacks an impact point, it is likely a stress crack. This leads us to the two ways windshield damage occurs. First is by impact with an object. Bullseyes, star brakes, and combination brakes all occur through impact. The second cause is stress. This occurs when the windshield has been forced into an unnatural position due to improper installation. This also occurs when the frame in which the window sits has been damaged. While you will be able to repair many different types of windshield damage with your new Delta Kit system, not all damage is repairable. Repair limitations are cited on the Repair of Laminated Auto Glass Standards, or ROLAGs, produced by the National Glass and National Windshield Repair Associations. We'll cover some of the most common limitations here, but we encourage you to review ROLAGs on your own. Damage that penetrates both the inside and outside layers of the windshield should not be repaired. The damage in this example occurred within 4 inches of another repair. Damage this close together in the primary viewing area can cause a blind spot for the driver and can interfere with the safe operation of the vehicle. It's also important to know what kind of glass can be repaired. Laminated glass can be repaired, but tempered glass cannot. Since 1937, the federal government has mandated that all vehicles sold in the United States use laminated glass in their windshields. And while laminated glass is used in the side and rear windows in some cars today, most still use tempered glass in these locations. To know for sure, look for the windshield bug. This is a stamp that will tell you who made the glass, what type of glass it is, and any special features the glass may have. Now we're going to introduce you to your new Delta Kit's windshield repair system. Note that the type of equipment you receive will vary based on which system you purchased. In this section, we will cover the basic tools and supplies in the order that you will use them during a repair. Included in the budget system, the scribe is a tool that is used to dislodge loose pieces of glass from the impact point before continuing with the repair. The steel tip is replaceable and will not scratch the windshield. Your system may have instead come with a spring hammer. A Delta Kit's innovation, the spring hammer also has a replaceable tip for cleaning the point of impact. Additionally, the spring hammer comes equipped with a depth gauge used when drilling and also has a spring-loaded hammer when creating a bullseye as necessary. Simply drill using a FG701 tapered burr to the depth of the gauge. Insert the sharp tip of the probe into the bottom of the hole and release the hammer. You'll have created a small bullseye that can be used to stop a crack in your customer's windshield. Your system included either a brush or a blower to clean the impact point. The purpose of this tool is to remove the remaining loose glass from the damage. The bridge assembly is the component that attaches to the windshield and holds the injector assembly in place during the repair. There are two different assemblies that you may have. Both bridges have a vacuum cup and two leveling screws. The leveling screws are capped with rubber feet to prevent damage to the glass and are used to level the bridge to ensure an even seal between the injector and the windshield. The B300 bridge uses a pump to attach the glass, while the B250 bridge uses a stainless steel flip lever. Once attached to the glass, if you need to make a small adjustment to the bridge position, loosen the adjusting nut, move the bridge as needed, and re-tighten to hold the assembly in place. If your system came with a B300 bridge, you will be working with the I100S injector. And if you have a B250 bridge, you will have an I100 injector. Both injectors are a sturdy stainless steel construction, use the same molded end seal, and carry Delta Kit's limited lifetime warranty. The I100 injector consists of three pieces: the barrel, the plunger, and the end seal. The end seal is installed in the barrel and must be oriented correctly. The cylinder in the molded end seal is wider at the top than the bottom where it comes in contact with the glass. You can also tell the top side by looking for the text imprinted on the rim of the seal. Be sure that this text and the larger end of the hole are placed into the barrel, or you will not be able to achieve adequate vacuum or pressure during the repair cycles. The I100 is unique in that it has a spring-loaded plunger that applies and maintains the correct amount of pressure during the repair process without the need for constant adjustments. This is a great feature if you are working on more than one repair at a time. The plunger can also be locked back during the vacuum cycles. The mirror included with your system is placed on the windshield directly behind the damage to be repaired. This gives you the advantage of being able to see both sides of the repair in greater detail, a great tool for achieving quality repairs. Because resin cures through exposure to ultraviolet light, it is important to protect your repair from sunlight until the repair is completed to your satisfaction. If your system came with a UV shield, simply place it over the bridge before starting the repair. There are several UV shield options that are presented in the product guide. Delta Kit's exclusive Magnabond fill resin is optically matched to provide high-strength clear repairs. Delta Kit's Premium Pit and Premium Pit Plus resins are a high-viscosity resin used to fill the impact pit after the brake has been filled with Magnabond resin. Curing tabs are used to hold the pit resin in place during the curing process and are designed to allow UV light to pass through. Surprisingly, many other plastics, including sandwich bags, actually block UV light and can prevent your repair from curing. Delta Kit's UV lights are made in the USA and emit a specific frequency of UV light to cure windshield repair resins. The lamp in your system is simple to operate and runs off either a 12 or 115 volt power source. Delta Kits offers other styles of UV lights that are detailed in the product guide found in this DVD. After curing the repair, a razor blade is used to remove the excess resin and make the repair flush with the windshield. This prevents interference with the windshield wipers. Pit polish is used in the final step to remove small scratches and shine the filled pit. Your system may have included a drill and carbide burrs. The instruction manual for this tool is included with your system, and we recommend following the manufacturer's instructions for its care and operation. Techniques for drilling glass are covered in the chapter on repair cracks. Some Delta Kit systems include two styles of carbide burrs, and their use is covered in the chapter on crack repair and use of the spring hammer. There's also additional information at our website. Because resin contains acrylic acid and other chemicals, personal protection is important. Your system includes material safety data sheets, which outline precautions and first aid for all of the included chemicals. Delta Kits recommends that you always wear hand and eye protection while performing repairs and when cleaning your equipment. Each system includes a barrier cream to reduce exposure to resins. You can also use nitrile gloves if you choose. Do not use latex gloves, as the resin will eat through the material. Safety glasses will reduce the chance of getting glass or chemicals in your eyes, and their use is strongly encouraged. Be sure to read the MSDS sheets and keep a copy of each in your toolbox should you have a spill or medical emergency. If you spill resin, clean it up immediately with warm soapy water before it has a chance to cure and dry out. Resin will etch the paint of a vehicle, so take every precaution to avoid spills on your customer's car. A hood protector is a great way to help prevent resin from damaging a vehicle. Denatured alcohol may also be used to clean resin from your equipment. Complete details on equipment care and cleaning are covered in the Care of Equipment chapter. Before you start any repair, it is important to assess the damage so that you know what you're dealing with before you begin. Delta Kits recommends using the ROLAG standard to determine what type of damage can be repaired and when a replacement is necessary. Ultimately, it is your decision on what type of damage you are or are not willing to repair. Be sure to explain this to your customers. If you're set up to bill a customer's auto insurance company directly for the repair, it's important to know what the driver's primary viewing area is. The driver's primary viewing area is considered to be 12 inches or 300 millimeters wide, centered on the driver's position and extending from the top to the bottom of the wiper sweep. You will likely be asked by the insurance company if the damage to be repaired is in the driver's primary viewing area. Refer to ROLAGs for more detailed information. One of the most important elements of a successful repair is setting realistic expectations for your customer. Outline the benefits of windshield repair that were discussed earlier in this video and stress that the number one goal is to restore the structural integrity of the car's windshield. It is also important for them to understand that the damage will not disappear and that a small scar will still be visible. Having an example to show them really helps to communicate this point. At Delta Kits, we tell customers that they can expect at least an 80% improvement in the cosmetic appearance after the repair. One invisible obstacle to a perfect repair is hydrophobic coatings that cause water to bead up and run off the windshield. If the windshield has a coating on it, the pit resin will not adhere to the glass and will pop out when you scrape the repair flush. To test for coatings, spray an area of the windshield a distance away from the damage to be repaired and see if the water beads up. If it does, the coating can be removed by scrubbing the area to be repaired with 4/0 steel wool. The coating will begin to ball up and come off the glass. Don't use a liquid chemical or other substance to clean the repair area, as this can cause moisture to enter the brake and prevent it from filling completely with resin. We'll cover tactics on how to deal with moisture in just a minute. The recommended glass temperature range for the best repair results is between 70 and 100 degrees Fahrenheit, or 21 to 38 degrees Celsius. If the windshield is too hot, the risk of it cracking out during the repair or cosmetic defects appearing is increased. The easiest way to begin cooling the glass is by getting the vehicle in the shade or indoors and opening the windows. You can also use the heat exchanger to spot cool the repair area. If available, you can also run the air conditioning through the defrost vents on a low setting to slowly cool the entire windshield. Because hot glass is more likely to crack out than cool glass, it's important to cool the glass slowly. Be sure to watch the brake during this process and stop immediately if you notice the damage spreading. A windshield that is too cold will cause the resin to thicken and can make it difficult to completely fill the damage. To slowly warm the windshield to within the recommended range, you have several options. First is to bring the vehicle inside a heated building. You can also turn on the vehicle's heater and slowly warm the glass from the inside. A hairdryer will also work to warm the windshield, but be careful not to overheat the glass when using this method. The last thing you should check for before beginning the repair is for moisture inside the brake. Moisture will prevent the repair from filling with resin and will create a void, visible as a black spot when the moisture is absorbed into the laminate over time. This will increase the chances of the repair failing down the road. A moisture evaporator is the most direct method of evaporating any water in the brake and will completely dry the damage. The added benefit of using a moisture evaporator is that it will also burn off any hydrophobic coating that may be on the glass. Remember to let the glass cool to within the recommended temperature range before beginning the repair. With the inspection and preparation completed, it's now time to begin the actual repair. We'll go through the process step by step for a standard repair and show each step in detail. Begin by taking your scribe or spring hammer and gently clean the pit of loose glass and use the brush or blower to remove any debris that remains. Next, take the bridge assembly and make sure that the adjusting screws and injector barrel are retracted so as not to interfere with the vacuum cup sitting completely on the glass. Make sure the adjusting slot is centered so that you have the maximum range if any adjustments are necessary once the bridge has been attached to the windshield. Orient the bridge so that the vacuum cup is above or to the side of the damage to prevent resin from coming into contact with the rubber and damaging it. Also, make sure that the injector is facing you for easy access. The B300 will be attached by activating the pump, and the B250 by flipping the locking lever to the horizontal position. Try and center the injector end seal hole directly over the pit when placing the bridge on the glass. You can check the position of the bridge by looking down the barrel, or by using a centering tool to ensure that the injector is directly over the pit. If the injector is not positioned correctly, it could interfere with the resin entering the brake. When the bridge is properly positioned, screw the injector barrel down until the head seal just touches the glass, and then advance it another half turn. Then screw the leveling screws down until they just touch the glass. You will then advance the leveling screws an additional 2 turns. At this point, the bridge should be level on the glass. However, additional turns may be required if the windshield you're working on has a significant curve to it. The goal is to uniformly compress the end seal against the glass. The amount of the end seal visible between the glass and the injector barrel should be equal all the way around. Another way to check the compression of the end seal is to measure the distance between the glass and the bridge plate with a ruler. Each of the 3 corners of the bridge should be within 1/8 of an inch of each other. Remember, this is a general guideline and may vary depending on the curvature of the glass. It is important not to over-tighten the injector or leveling screws. Doing so will compress the glass and prevent it from filling with resin, or cause the glass to crack further. Watch the damage area while installing the bridge and stop immediately if you see the damage spreading. You are now ready to load the injector with Magnabond resin. It takes approximately 7 drops of resin to fill most pieces of damage. The proper amount in the dropper is represented by filling it to where the taper of the dropper tube is the midpoint of the resin level. Insert the dropper tube to the very bottom of the injector barrel. The goal is to completely fill the end seal with resin so you will have sufficient fluid pressure during the repair and avoid injecting air into the brake. After filling the injector, close your resin bottle. If capping the bottle with the dropper, you just need to tighten it until the lid is snug. Over-tightening will cut the dropper bulb by pinching it between the bottle and cap. Returning the bottle to the toolbox will prevent spills, breaking the bottle, and UV light from affecting your unused resin. If using the I-100 injector, take the plunger and set it into the vacuum position and install it into the injector barrel. Screw the plunger down until it stops. There is no need to over-tighten the plunger. While holding the injector barrel with one hand, pull back on the plunger and rotate it 1/4 turn clockwise and gently lower it into your first pressure cycle. Apply a slight amount of thumb pressure at this point. Leave the plunger in the first pressure cycle for 5 minutes. The I-100 injector does not require supervision during the pressure cycles. You can leave the glass repair to sit and begin a second repair, finish paperwork, or get started with another customer. Leaving the injector in either the pressure or vacuum cycles for longer than the recommended times will not adversely affect the quality of the finished repair. After the first pressure cycle is complete, hold the injector barrel still with one hand, pull back on the plunger, and rotate 1/4 turn clockwise so that it locks back into position. This is called a vacuum cycle and starts to remove the air from the brake. Leave the injector in this position for at least 30 seconds. Using the same techniques, complete an additional pressure cycle of 2 minutes. A second vacuum cycle of 30 seconds, and always end on a pressure cycle. Additional pressure and vacuum cycles may be necessary depending on the complexity of the brake. 2 to 4 cycles on average are required. The end result should be that all of the air has been removed from the brake. When air is present in a brake, it will look either black or green in color, and in some cases have a shiny or rainbow color. Repeat the same process for the I-100S injector assembly. Be sure to closely inspect the brake before removing the bridge. The bridge can be rotated for better visibility by loosening the adjusting nut. Look at the brake from multiple angles. Air pockets may be invisible from one angle, while obvious from another. Remember, once you cure the resin, you won't be able to extract any more air or inject more resin. When you're sure that the brake has been completely filled, you can remove the bridge by gently lifting up an edge of the vacuum cup. Be sure to first place the locking lever in the vertical position if you have the B250 bridge. Set the bridge down on a paper towel and cover from any UV light. Take the bottle of pit resin and carefully place one drop directly below the pit. By slowly squeezing the bottle, you will minimize any air bubbles. Once the pit resin is on the glass, apply the curing tab. Do not push on the curing tab, as this will force the resin out of the pit. If there is an air bubble in the drop, or even if you see one after applying the curing tab, you can use a straight pin to pop them. Remember to do this before curing the resin. The goal is to leave a small hump in the resin to ensure a flush repair when finished. Place your UV lamp over the repair and turn it on for 5 minutes. Moisten the suction cups with a small amount of water for a secure grip. Be sure to place your lamp in such a way that the resin does not get on the cups, as this will damage them. Wipe up any excess resin if necessary, but do not disturb the repair. After 5 minutes, remove the lamp by breaking the suction of each cup. Do not pull the lamp, as this will cause the suction cups to break free of the lamp. Remove the curing tabs and use a new razor blade. Hold it at a 90-degree angle and scrape the resin flush with the surface of the glass. When all of the excess resin has been scraped off, take a dab of pit polish to polish the surface of the repair. Pit polish will not harm the surrounding glass and will improve the appearance of the final repair. Proper burr selection is important to consider when preparing to drill into a windshield. Here we're going to define the 3 situations when drilling is necessary and what to consider before starting. The first situation in which you will need to drill is when terminating a crack. Drilling a hole is an important step in the process and allows the crack to be anchored and prevent it from spreading across the windshield. View the segment on crack repair to see this process in detail. Capping a pit is the second situation requiring drilling. After curing a resin cap over a large pit, a hole must be drilled to allow the damage to be filled with resin. For cosmetic reasons, use a burr that makes the smallest diameter hole, though any burr will work. Remember, the larger the hole, the more visible the finished repair will be. If you've been working on a repair and there is a pocket of air that will not fill with resin, it may not be connected to the main part of the brake. When resin will not flow any other way, drill a hole and reset your bridge to fill the area. Before beginning, plan where you're going to drill the hole and what type of burr is best for the application. Remember, you never want to drill through the layer of glass and into the laminate. This will increase the risk of flowering, a cosmetic defect in the repair, and it can cause the burr to break off in the glass. The spring hammer has a depth gauge built in that is used when drilling to make the controlled bullseye needed to terminate a crack. Be aware, however, that glass thickness can vary across manufacturers and their various products. After selecting the appropriate burr and securing it in the drill collet, turn on the motor and brace the drill using both hands, as this adds stability. Hold the drill approximately 45 degrees to the glass and gently touch it to the surface to begin. Do not use much pressure in this stage, as the burr can catch and skip, scratching the glass. Slowly rotate the base clockwise to allow shavings to exit the hole. Be sure to check your depth often and thoroughly clean the hole of any shavings before proceeding with the repair. As defined by roll lags, a short crack is anything 6 inches in length or less, while a long crack is anything over 6 inches. Cracks can appear anywhere on a piece of glass and have multiple causes. A stress crack is one that extends from an edge but does not have an impact point. These cracks are caused by stress in the glass due to improper installation, the windshield frame being damaged or altered, or inferior quality of glass. Regardless of the type or cause of the crack, the procedure for repairing them is the same. However, there is a higher risk of the repair failing with stress cracks, as there is no way to determine the extent of damage to the glass where it is hidden by the windshield molding. Inspect the damage, checking the size of the pit and which layer of the glass is cracked. If the crack is in the inner layer or light, a repair is not recommended. To start the process, locate the end of the crack by gently flexing the glass. You'll notice that the crack appears to grow, and you can see where the brake actually stops. Be careful not to use too much pressure, which could cause the crack to run. Drill a hole about 1/32 of an inch past where you saw the crack stop. A popular option is to drill about 2/3 through the top layer of glass and use a spring hammer to create a small bullseye at the end of the crack. The bullseye works well to terminate the crack, and the spring hammer has a built-in depth gauge, so you can drill to the proper depth every time. If you don't have a spring hammer, a bullseye can be created by inserting a probe tip into the drilled hole and lightly tapping the end of the probe. Remember, it does not take a lot of force to create the bullseye. Now apply a light pressure to the glass so that the crack runs into the bullseye you just created. This will keep the crack from spreading after you finish the repair. Just as in chip repair, the recommended temperature range for a crack repair is between 70 and 100 degrees Fahrenheit. An important point to remember is that hot glass is more prone to cracking out than cooler glass, so ideally the glass would be at the lower end of the temperature range. The damage should be completely dry before beginning the repair. If you do see moisture, you can dry it out by using a heat gun. Remember to cool the glass back to within the recommended temperature range before progressing with the repair. Using the tip of your spring hammer or probe, pick any loose glass or other debris from the impact point and brush the area clean. Place the inspection mirror behind the impact point for the best visibility. Attach the bridge assembly to the glass in the same manner as you would if doing a chip repair, placing the bridge at the impact point or drill hole, whichever is lower on the glass. Load the injector with approximately 7 drops of resin and place the injector into a pressure cycle using the same steps you would with the chip repair. You will leave the injector in this pressure cycle until the crack has been filled with resin and cured. Switching to a vacuum cycle will cause air to be drawn into the brake. You will see resin start to fill the crack. When the resin's progress stops, use the resin dropper to apply small amounts of resin directly to the crack just behind where the resin has progressed. The resin will draw into the crack and fill it seamlessly. It's important not to introduce resin ahead of where it has naturally progressed, as this will trap air in the brake. As the crack is filled, cover it with curing tape to keep the resin in and the air out. When the entire crack is filled, protect the bridge and injector from UV light with a thick towel or other barrier. Once the bridge is protected, you can cure the length of the crack using your UV light. If you don't have a tube UV light, you may have to move the light several times to fully cure the entire crack. Once the crack has been cured, finish filling the bullseye you made or impact point just as you would with a standard chip repair. Then, if necessary, repeat the chip repair process at the other end of the crack. It is important not to rush the process to avoid trapping air bubbles in the finished crack. Alternative methods may also allow air bubbles to be trapped within the resin in the crack. Crack expanders and/or thumb pressure as well as heat are not recommended unless the basic method is unsuccessful. Remember that cracks will always be visible from certain angles and in certain lighting conditions, even after being successfully filled and cured. Because of the stress on long cracks and the inherent problems in repairing them, the success rate is approximately 25% lower than the success rate of an average windshield repair. Customers should be made aware of these facts before any long crack repair is attempted. For additional information on these topics and more, visit us at www.deltakits.com or call us at 1-800-548-8332.